Kristen's attending, or Kristen's kitty is attending in her place this morning. Okay, Trinity's back in. I don't know why. It said when I start recording, it was going to kick you out, Trinity. There was some kind of technical issue. I'm glad you were able to rejoin because something weird was happening when I started the recording. But anyways. All right. Well, we're going to get into our long division with polynomials. So excited. This is the only class I get to do that with. It's just my Algebra 3 courses. But let's dig in that. It's going to take us some time today to dig into this because we haven't done long division in a long time. I didn't mean that to be a pun, but it's been a long time since we've done long division. So we're going to go to take a look at what this contains. Algebra 3, if we go to our grade screen, we can see that we are now done with the first two modules. 100%. All this was done. The module 2 test, along with the graphing transformations, that was due last week's. That was last week's assignments. So that's past due if you haven't got the test turned in yet. So we are starting module 3 with polynomial long division. Yes, it's just like it sounds. We're doing 2 lessons. So after we do long division, then we're going to do synthetic division, which if you've never done before, you're going to like this a lot. So we're going to get into that. So, all right. Hey, there's a lot of cameras off, guys. Let's turn some cameras on. We're in class. It's Monday. I want to see some faces today. I don't want to talk to a blank wall. Besides, I like seeing Kristen's kitty there attending class. So I don't have any kitties in my house anymore. But if Kristen's kitty wants to learn some polynomial long division, I'm all for it. That's awesome. So, all righty. And we may have our principal pop into class today. Teachers are touring other people's classrooms, so you may have been in a class that's done it. But the teachers are visiting other teachers just to see how they teach. So if we have a visitor today, don't be surprised. It'd be Miss Scott with probably 2 or 3 or 4 other teachers. Maybe the English squad. I'm not sure which teachers. I think it's the English squad. All right, polynomial long division. Let's look at 3.01. So we can close module 2 now. So we've got 2 folders that we are complete. We're going to look at module 3, starting with polynomial long division lesson, synthetic division lesson. So we're going to have some fun stuff to do today. But we're going to have a little review on long division and then try it with polynomials. Crazy stuff. Polynomials in the real world. So a cantilever, you've seen these big cranes. A cantilever is a beam that's anchored only at one end that can bear the weight of some force. So these beams are used in a variety of applications, from bridges to airplanes, micro-electromechanical systems. The bending of a cantilever undergoes a third-degree polynomial function of the leak. So that's how they figure out how much weight these cranes can hold, these great big cantilevers. It's only hooked up on this end, but they can put a whole lot of weight on the other end. They've got some weight on this end to help balance it out. But there is a third-degree polynomial function to calculate that by some engineer figuring out how much that crane can hold. So many real-world situations can be modeled using polynomial functions. So we've got to know how to use them. So a key feature is when these are set to 0. When we make a polynomial function equal to 0, it makes it easy to construct a rough graph and know how the function is going to behave. So after we complete this assignment, we're going to be able to know how long division can be used to find the factors of polynomial functions. So when you first learn long division, a long time ago, like 10 years ago, when you were just a little pumpkin, you probably didn't understand really what you were doing. What was its purpose for long division? Now that you're older and wiser, you see a lot of uses for knowing how to divide. Knowing how to divide is really useful. Let's say you got a part-time job working in a bakery. So the bakery sells a bag of rolls containing 13 rolls, which is known as a baker's dozen. You buy 12, we'll throw an extra one in free. It's called a baker's dozen. So the baker made 158 rolls before they left. And they said, hey, get all those bagged up before you go home. How many bags do you need? Should you try to sell some leftover rolls so you don't have any extra rolls so you don't have any leftovers? Does 13 go into 158 exactly a number of times? So this is a situation you may encounter in lots of jobs, just doing different type of things, grouping a given number of items evenly. Here you need to put 158 rolls into groups of 13. In order to find out how many bags you create, you got to divide 158 by 13. Let's see a review on that. Which, no, it doesn't go in evenly. So let's look at this. So divisor, quotient, dividend. Those are the terms we use in long division. The divisor is what you're dividing into a number. Yeah, you bet, Shay. The dividend is what you're dividing into. And then the quotient is your answer. That's what you get. So like when we're dividing 158 by 13, 158 is our dividend. 13 is our divisor because we're dividing 13 into 158. So the first thing we see is we need to figure out how many times does 13 go into the first digit. It does not go into 1. So we skip that. And now we look at the first 2, right? 13 goes into 15 one time. So we put a 1 up on top. Then we multiplied 1 times 13. And we subtract. 15 minus 13 is 2. Then we bring down the 8. Bring down the 8. Now we divide 13 into 28. 13 goes into 28 2 times. So we add a 2 up at the top on our quotient. Multiply 2 times 13. That has a remainder of 2. There's no more digits to bring down. 8 was our last digit. So now we know when we divide 158 by 13, it's 12 and 2/13, right? 12 full bags of rolls, and there's only 2 left over for the next bag of 13. So there's 2/13 left over. So 13 divided into 158 is 12 and 2/13. And then you can always check that by multiplying backwards. If you multiply that by 13, this cancels out. All right, you can write this first as a improper fraction. 12 times 13 plus 2 is 158. And when you multiply it back, you get the original. So 12 bags are needed. And then you got 2 rolls that if you could sell those to somebody before you leave, you wouldn't have any leftovers. Nothing to get rid of. Just a nice review of that. Let's see. The steps used to divide polynomials are the same steps when using to divide integers. Oh, right. Here's a phrase. Discovering math solutions bring rewards. You divide, you multiply, you subtract, you bring down the next one, and you repeat if you need that. All right, here's a video where we're going to divide. Oh, I love this. 2x to the third minus 10x squared plus 18x, and we're going to divide it by 2x. So we'll see how long does this take them to do that. 4.5 minutes. So let's watch this video together. And then we're going to do some of this on paper. So have pencil and paper ready. You want pencil and paper ready so you can take notes because you're going to want some notes on how to divide when we do this. So, but I'll play this video. Remember, you have this video. If you need to go back and review it yourself, you have it in page 1 of our lesson.
Before you can start with the division process, you need to set up the problem. The dividend is the trinomial 2x cubed minus 10x squared plus 18x. And the divisor is the monomial 2x. Remember, the steps in the division process are divide, multiply, subtract, bring down, and repeat. First, divide. How many times will 2x divide into 2x cubed? You can think of this as dividing 2x cubed by 2x. 2 divided by 2 is 1. But what is x cubed divided by x? When you multiply variables, the exponents are added. When you divide variables, the exponents are subtracted. So 2x cubed divided by 2x is 1x squared, or just x squared. This gives you the first term in the quotient. Next is multiplication. Multiply x squared by 2x. The product is placed underneath the first term of the dividend. Then it's time for subtraction. Subtract 2x cubed from 2x cubed. Now bring down the next term. Remove the 0 since adding or subtracting a term from 0 doesn't change the value of the term. Repeat the steps of long division until all the terms of the dividend have been exhausted. Time to divide again. Divide negative 10x squared by 2x. You can think of it this way. Negative 10 divided by 2 is negative 5. But what is x squared divided by x? Subtract the exponents. So negative 10x squared divided by 2x is negative 5x to the first power, or just negative 5x. Place this above the second term of the dividend. Multiply. Negative 5x times 2x is negative 10x squared. Subtract. Negative 10x squared minus negative 10x squared is 0x squared. Bring down the next term. Again, you can remove 0x squared since it just has a value of 0. Repeat the process. Time to divide again. Divide 18x by 2x. You can think of it this way. 18 divided by 2 is 9. What is x divided by x? Think about it. What is 11 divided by 11 or 100 divided by 100? The answer to all these questions is 1. Any number or variable divided by itself will result in 1. Another way to look at it is through the subtraction of exponents. Any number or term raised to the power of 0 equals 1. So 18x divided by 2x is 9. Place this above the third term of the dividend. 9 times 2x is 18x. 18x minus 18x is 0x. There are no more terms to bring down. Therefore, the quotient has been found. The answer is x squared minus 5x plus 9. Check your work by multiplying the quotient by the divisor. This product is the same as the dividend, so the quotient x squared minus 5x plus 9 is accurate.
All right. You might be wondering, why would that be useful? Well, what if you need to factor this? 2x to the third minus 10x squared plus 18x. Like, what's all the factors of that? Well, I don't know. It's an x to the third. We generally don't factor that much. Well, if you know there's a 2x in every term, if we factor out 2x, now this leaves a quadratic formula. We can factor a quadratic equation. We can use a quadratic formula, or we can factor it, or factor by grouping, or complete the square. There's lots of ways to factor this. So, 2x is one of the factors. The other two factors would be found by finding the factors of the quadratic equation that's left when we took out the first term. So that's how the division, polynomial division is used, is to find the factors. So this is more, there's another example. If you need another example on dividing a polynomial by a monomial, negative 3x, this will walk you through all the steps. In the interest of time, I'll leave that for you to review because we got a lot to cover today. All right, polynomial division of a polynomial by a polynomial, not just one term. Look, we're dividing x squared minus 2x plus 4 by x minus 6. A little bit more complicated. Let's watch this video on how to do that.
Divide x squared minus 2x plus 4 by x minus 6. First, set up the division problem, where the dividend is x squared minus 2x plus 4. And the divisor is x minus 6. When dividing integers, the digits in the dividend were evaluated separately. With polynomials, focus on the terms. There are two terms in the divisor. So count over two terms in the dividend to determine where the first term of the quotient will be placed. When dividing a multiple-term polynomial, the first term of the dividend is divided by the first term of the divisor. So ask yourself, what is x squared divided by x? Next is multiplication. Similar to division by a monomial, the quotient will
Okay, let me pause that for a second because that's important to understand. If we're dividing by x minus 6 and we're dividing into this, there's two terms here, so we have to look at the first two terms here. But we only divide whatever the first one is. We don't care about the minus 6. We didn't use that to determine how to divide into this. We only look at the very first term, and we only divide into the very first term. So we only looked at dividing the x into the x squared. We don't care about the negative 6. We don't care about the negative 2x at this point. We're just looking x goes into x squared how many times? It goes an x number of times. All right, let's continue.
be multiplied by the divisor. Multiply x by x minus 6. Be sure the quotient is distributed to both terms of the binomial divisor. Place the product underneath the first two terms of the dividend. Now it's time for subtraction. Be very careful here. When subtracting a binomial, there is a -1 that needs to be distributed to each term before like terms may be combined. Once the -1 has been distributed to each term, the subtraction sign becomes an addition sign, and the like terms may be added. Bring down the next term. Repeat the steps of long division until all the terms of the dividend have been eliminated. Time to divide again. Divide 4x by the first term of the divisor x. Place this above the third term of the dividend. Since 4 is positive, it is added to the first term of the quotient. Multiply 4 by x minus 6. Subtract. Don't forget to distribute the -1. There are no more terms to bring down. Therefore, 28 is the remainder. Remainders are written as fractions, with the divisor as the denominator. The quotient of x squared minus 2x plus 4 divided by x minus 6 is x plus 4 plus 28 over x minus 6. Notice that there is an addition sign between the fraction and the rest of the quotient. This is because the remainder is positive 28 and being added to x plus 4 rather than being multiplied. You can think of the remainder as another term of the quotient.
All right, so when we divide x minus 6 into x squared minus 2x plus 4, the answer is x plus 4 plus 28 x minus 6's. There's a remainder. What that tells us is if we were to factor this quadratic, this is not one of the factors. Because there's a remainder, it does not go into it evenly. It has to go into it evenly for that to be a factor. If we had a remainder of 0, this would be one of the factors of that quadratic. But it is not. So, all right, more examples. Let's do this one on paper. So they're going to, let me write this down. They're more legible there. 9x squared plus 6 is what f of x is, and g of x is 3x minus 1. And they want us to take f of x and divide it by g of x. So g of x goes outside. Inside, now this is interesting. Watch what I'm doing here. 9x squared plus 0x plus 6. This is the same equation. But if I'm going to be dividing into it, I have to account for every term. And since I did not see an x there, I'm accounting for it with a 0 here. There are 0 x's, but if I divide, I need that x in there for this to work properly. So that's a very important part of doing this correctly, is to account for the missing terms. All right, so to divide this, we're taking 2 terms here, so we need to look at the first 2 terms here. But we only care about the 3x. How many times does 3x go into 9x squared? 9x squared divided by 3x. That's all we're caring about to figure out our first quotient number. 9 divided by 3 is 3. X squared divided by x is x, right? Because it's x times x over x. X squared divided by x. These cancel each other out, leaves just an x. So 3x goes right here. Now we multiply, and we have to multiply it times everything to put it underneath. 3x times 3x is 9x squared. 3x times -1 is minus 3x. Now we have to subtract this. Remember, when you're subtracting, 9x squared minus 9x squared, that goes away. But 0 minus a negative means we add it, 3x, and bring the next term down, plus 6. So now we're looking at 3x minus 1 divided into 3x plus 6, but we only look at the first term. 3x divided by 3x is just 1. So let's multiply 1, 3x minus 1. Subtract all of that. Put that in parentheses to remind yourself. If I don't put the parentheses, I might subtract this and forget that this is being subtracted. Put that in parentheses. 3x minus 3x, that just goes away. 6 minus -1. 6 minus -1 means plus 1, 7. So we have a remainder of 7 3x minus 1s. So when we divide, this is our answer. I guess I can put it right here. 3x plus 1 plus 7 3x minus 1s. That's what we get when we divide f of x by g of x. We get 3x plus 1 plus 7 over 3x minus 1. 7 looks a little squiggly. Let's straighten him out a little bit. They set it up. 3x goes into 9x squared 3x times. Multiply. You get 9x squared minus 3x. Those canceled out. You're subtracting the 3x, so it adds it. Bring down the 6. Repeat. 1 times. 3x goes into 3x 1 time. 1 times 3x minus 1 being subtracted again, adds 1. 3x plus 1 plus 7 3x minus 1s. Okay, that's what we did. So what would have happened if we didn't put that 0x in there? That's what I said. You got to account for that x term. Let's see, what would that do? It would give us the 3x, and it doesn't line up because it would be above a 6. We can't combine those. See, when you bring this down, the x terms with the x term. So we can do those. But what do you do when you're subtracting the 3x from 6? That doesn't work. So these have a remainder. That indicates the divisor is not a factor. So we'll get more into that. All right, application. Oh, here's a good application. So let's say you have a box and the volume is x to the third plus 4x squared minus 31x minus 70. If you know the length and you know the width, it wants to know how tall is the box. Okay, so it's using this equation, volume equals length times width times height. If you want to know the height, so it's saying the volume equals length times width times height. If we want to know what the height is, let's divide by the length and the width. I'll make that a capital L. So if we divide both sides by the length and the width, the height equals the volume divided by the length times the width. Right? It's just rearranging equations. If we have this equation, V equals LWH, and we need to know H, just divide the LW to get to the other side. So knowing that, and going back to our original equations, if we know that's the volume, the height is the volume divided by these two, which is the length and the width. The length and the width is those two terms. So you can multiply those together first. That'd be x squared plus 2x minus 35. So if you divide the volume by the length times the width combined, that'll give us our height. So it says, okay, divide that and figure out what is the answer. So let's write this down then and see if we can come up with the answer that we're supposed to type in on this page. Okay, so here is the volume, and here's what the length and width are when you multiply them together. So we've got to do polynomial long division with a third degree and a second degree. But again, we only look at the first term when we're figuring out. Now we're going to take into account we're doing three terms, so our first answer is going to go right here. It's a terrible arrow. My arrow isn't working good today. It's going to go right here above the third term because we're dividing three terms into three terms. But we only care about this. How many times does x squared go into x to the third? X to the third divided by x squared goes x times. X times. Now let's multiply. X times x squared is x to the third. X times 2x is 3x. I'm sorry, not 2, not 3. It's 2. The number didn't change. 2x squared, because I'm just multiplying by x, minus 35x. All right, so I just took this and multiplied the x. X to the third plus 2x squared minus. Hope you're writing this down. This will be a good example to have in your notes because this is only easy when you practice a lot. When you look at it first, you're like, oh my gosh, how are we doing long division with these big, nasty polynomials? Just like this. Remember, we have to subtract, and we have to subtract everything. So x to the third minus x to the third, that cancels out. 4x squared minus 2x squared, 2x squared. 31x, negative 31x minus negative 35x. Minus a negative. That means we're adding 35. So this is plus 4x. Okay, now we need to bring this down. And ready to start over. How many times does x squared go into 2x squared? It goes in there 2 times. Multiply. 2 times x squared is 2x squared. 2 times 2x is 4x. And 2 times negative 35 is negative 70. If we subtract, this cancels out, that cancels out, that cancels out. So there's no remainder. This is the answer. So this is the height. That is the height right there. And our width, or one of those other ones, was x plus 7 and x minus 5. So that's the dimensions of the box. X plus 7, x plus 2, x minus 5. So we can take a look back at our lesson. So we said x plus 7, x minus 5, and we calculated the height to be x plus 2. That's correct. X plus 2. So then they work through the same thing there if you want to see the solution. But that's just what I did on paper to come up with the x plus 2. But if you need that for your notes, and there it is, nice clear on the screen. If you want to copy those down, it is right here on page 3. Put in the x plus 2 and hit solution, and it'll show you. Lesson summary. Let's look at another example on polynomials divided by polynomials. All right, let's try another example. All right, so we're dividing x plus 7 into 4x squared plus 27x minus 7. So two terms. So we're going to look at the first two terms, and we're only going to look at the first term. Remember, that's the important thing. When I'm trying to figure out how to divide this, I only care about the first term. So I'm looking to see 4x squared divided by x. What do we get? That looks like a y. Ooh. That just equals 4x because we divided one of the x's out, and that's it. So this goes in 4x amount of times. And I put the x over the x term. I put it over the last term that we're looking at. First two terms. Multiply. 4x times x is 4x squared. 4x times 7 is 28x. And I'm subtracting 4x squared minus 4x squared. That cancels out. 27x minus 28x. 27 minus 28. Negative x. Bring this down. How many times does x go into negative x? Negative x divided by x goes in negative 1 times. All right, because we multiply negative 1 times x, that gives us negative x. Minus 1. So multiply. Negative 1 times x is negative x. Negative 1 times 7 is negative 7. When we subtract that, remainder of 0. So that tells us something. If we have this quadratic equation, and we're like, man, that would be nasty to factor that. Well, we just did it. It factors to x plus 7 and 4x minus 1 because this is a 0. So these are factors. So this and this. Those are the factors of this. So that means if we're trying to find out the x solutions, x plus 7 equals 0. So x equals negative 7. And 4x minus 1 equals 0. So add 1. 4x equals 1. X equals 1/4. So that was a way that we used to solve this. If we want to find the solutions, it's negative 7 and 1/4. And we did it by long division. We said, I think this is a factor. I think this is a factor. So if I divide it in there and get a 0, then yes, it is. Because this is 0, this is a factor. This is a factor, and that's the other factor. That's the two factors. Because the remainder was 0. If this was any other number, that didn't work. Those are not factors. But that tells us a lot when the remainder is 0. So that's great to have in your notes. That when this is 0, that means these numbers that you got are the factors of that equation. Useful stuff right there. But you're like, Master Brock, this polynomial division. Oh my gosh. Yeah, here's another one. I won't work this one for interest of time here. Step division problem was the dividend. So this is the part that goes inside the dividing symbol. See, that's this part. The divisor, the part that goes outside, is this because you're dividing by that. But you got to put the 0x. This is one of them that's going to try to trick you. Anytime you're missing a term, you have to account for that term. So you have 0x in there. So you have x squared plus 0x minus 3 divided into 2x to the fourth minus x third minus 3x squared plus 7x minus 12. So you look at the first three terms. How many times is x squared going 2x to the fourth? It goes in there 2x squared number of times. Then you multiply that back, but you're multiplying it times that 0x. So you have 2 times 0 is 0, but x squared times x is 3x squared. But see how that's important, because you need that middle term to line up with that middle term. You have negative x to the third, and you're subtracting 0x to the third, so that's not going to change. So you're going to subtract it. You just have negative x to the third coming down, and this changes to a positive 3x. Then you drop the next term down. See, now you're using all three terms, x third, x squared, and x. So that's going to line up with this. It's going to go, x squared is going to go into negative x third, negative x times. And then when you multiply it through there, negative x times this is negative x to the third minus 0x squared plus 3x. Every time you get that 0, that's going to appear because you have that in your divisor. And when you subtract that, you get this, which means we got to bring another 12 down, minus 12. How many times is x squared going to 3x squared? Goes in 3 times. So 3 times this is going to be 3x squared plus 0x minus 9. And when you subtract that, you're going to have a remainder of 4x minus 3. So the answer is 2x squared minus x plus 3 plus this remainder of 4x minus 3 over x squared minus 3. You don't have to put the 0x in your final answer. But it does not divide evenly, so this is not a factor of this. Not a factor. But you have to include that 0 in there. Lesson summary. There's the steps. If you want to write those down, divide, multiply, subtract, bring down, repeat. But those steps you've known since you started dividing numbers in first or second grade, whenever it was. Probably first grade. Take 7 divided by 3. You know, multiply, divide. You've known that for a long time. Missing terms. This is great to have in your notes. When either polynomial does not have all of its terms, it's necessary to add them in with 0 coefficients. Oh, that's so important. You're going to get such a wrong answer if you forget that. I don't want you to get a wrong answer. I want you to remember this. See, that one's missing x squared. There's no x squared there, so you got to add that in there. This one's missing a bunch. X to the fourth minus 1. You need the third, the second, and the x term. And then if the quotient has no remainder, which is remainder 0, the divisor is a factor. All right, so here's what's important for this is you've got a lot of practice problems. Because you have to practice this for it to feel easy. I want you to divide this by 5. Look, here's 3 problems right here. Divide that by 5, which means you'll get that. Then you can see the next problem. This one you divide by 7x. So these starting out are just dividing by one term. Dividing by one term. So that won't be too terribly hard, right? You'll get that. See the next one. It's divided by 9x. It's still just one term. Then you go over here, and here's some more problems. Divide all of this by x plus 7. Now dividing by 2 terms. And then when you're done with that, there's another problem. There's 3 altogether here. Dividing by 2 terms. Dividing by 6x plus 1. Oh, there's a missing term. There's x squared and a 7. You've got to put that 0x in there. So there's 6 problems for you to practice on this page. And then you go to page 5. Match each division problem to its correct quotient. So this is an answer. So you got to work all 6 of these on paper. And then they should match up to these answers. Oh, I'm sorry. These are the answers up here. I have it backwards. You got to work this problem and then figure out which one of those is the answer. So it should have 6 problems for you to do, but the problems will only be there one by one. Divide 40x squared plus 8x plus 20 by 4. And then when you get done, you just drag that to its answer, and they'll give you the next problem. Give you the next problem, and you can reset that. But yeah, there's 6 more problems. And look, there's 3 pages. So when you're done with all of these, there's another page. And then when you're done with those, there's another page. So there is plenty of practice problems. And remember, if you mess it up, it'll give you the answer at some point. See, it's not let me do that. That's not the answer. But you can get the answers, and it'll show you how to work it. All right. That is the end of that lesson. Polynomial long division. Don't get to do that very much. Let's go back and look at the assignment that goes with that. Polynomial long division. Start. Divide this by 7x. Divide this by 8x squared. So these start now with just one term, dividing by one term. Then we're dividing by 2 terms. X plus 5, 2x plus 5. Let's see what the last one. Oh, this is like the volume one that I did. You have the total volume. It's this big X to the third. Then they give you the length and the height. So they want you to figure out what is the width. So multiply these together. Or you can do long division twice. You don't have to multiply them together. You could take X plus 2 and divide it into this. And then whatever you get as an answer for that, divide X plus 8 into that answer. So you could do long division twice, or you can multiply these together. Right? You can multiply these together. And you're like, Mr. Brock, what are you talking about doing it twice? Well, think about that with just regular numbers. If I know that I have a width of 2, a length of 3, and I need to know the height, and I know the volume is 24, I could take 2 divided into 24. I made a square root. I'm so used to using the square roots. It's hard to go back to just division. I could divide 2 into 24 if I wanted, and that would be 12. Then I would divide 3 into the 12, and it goes 4 times, so I know the height is 4. I divided twice. First, I divided this into the 24, and whatever the answer was, I divided the 3 into the answer, and I got 4. Or I could multiply these together. 2 times 3 is 6, and 24 divided by 6 is 4. So it depends whether I want to divide twice or I just want to divide once. Either way. The only difference is if you only divide once, you're dividing by an x squared, like this one. If you're dividing twice, you're dividing by just binomials. But you have to do it 2 different problems. So whichever you want to practice with, whichever you feel comfortable with. But that's what this is. And if you don't get one of these 4 answers, you did something wrong. So maybe try it the other way. But that is the 5 problems. Oh, I have to do that assignment before I can do this one. All right, well, let me go answer something just so we can do that. 7x, it's going to be this one. Let's see, this one's going to be this one, x plus 5. That one's a little trickier in my head. I'm gonna guess that one. And let me guess this one real quick. We're gonna guess that. And then the volume of that, I'm just gonna throw a wild guess out there. All right, so I'm gonna turn those in so that now I can go look at the next answer. Oh, I got an 80. That's not bad. Just guessing. All right, now I can look at the next lesson. So until you do the polynomial division, you can't look at lesson 2. All right. Let me talk about synthetic division first. Polynomial division. Maybe your head's kind of spinning now like, wow, I never dreamed we'd be doing that when you learn long division in 1st grade, right? But yes, we can do that. And you see it works. We can find factors of that. And after you practice this and you get good at this, Now we got synthetic division. And synthetic division is like a cheat code on your favorite video game. It's a cheat code because you get to skip a whole lot of the work and jump straight to the answer. Oh, Mr. Brock, why didn't you show me this first? Well, it's just like when you play a video game. If you don't learn the hard way to do it, you don't appreciate the shortcut. You appreciate the cheat code when you had to go through and solve it the hard way the first time. Then it's the cheat code. I can just jump straight to the solution. That's what synthetic division is. We're going to jump straight to the solution. All right, let's see what they're showing us here. Because it's like, okay, this sounds really cool, Mr. Brock. I'm all about this. Let's jump straight to the solution. Starting out, it wants us to try the following problems. Let's add the numbers 3, 3, 3, 3, 3, 3, 3, 3, and 3. Oh, let's see. So we're going to add 3, 3, 3, 3, 3, 3, 3, 3, and 3. So let's see. 3 plus 3 is 6, plus another 3 is 9, plus another. And you're like, Mr. Brock, are you really going to do this? Okay, I won't do that. But yes, we know that that is what we learned first, is adding all of these and another 3. But later on, we learned a shortcut, didn't we? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9 is 27, which means if I kept adding, I would get to 27. Cheat code. Multiplication became a cheat code for addition. Oh, yeah, I remember that, Mr. Brock. If you asked this in elementary school, you probably would have added them all, because until we learned multiplication, we had to do that. But then, since there's 9 3s, we just multiplied 9 times 3, get 27. We did. We jumped out of the middle and just said, okay, I'm going to go straight to the answer. How about this? Is 45,789,102 divisible by 3? Well, that looks like a long division problem, Mr. Brock. We're going to have to take 3 and divide it into there. Well, hopefully you didn't actually do that. You could just find the sum of the digits. That's a shortcut. If we add those together, 4 plus 5 is 9, plus 7 is 16, plus 8 is 24, plus 9 is 33, plus 1 is 34, plus 0 is 34, plus 2 is 36. And 36 is divisible by 3, so we know 45,789,102 is also divisible by 3. Cheat code. Add the digits. Is that digit divisible by 3 when you add them up? Oh, I love it. Multiply 34 and 11. Well, we could do that. You know, multiplication, carry the 1, all that kind of stuff. Or we can say, oh, wait a minute, that's just times 11. So the quickest way to do that is with 11, you just take the 3 plus the 4. Find the sum of the digits that place the sum in the middle of those digits. We've got the 3 and the 4. See the 3 and the 4? And you add those together, and that means there's a 7 in the middle. So 34 becomes 374. Because when you multiply by 11, you can do that. If you have a 2-digit number multiplied by 11, take that 2-digit number and put the middle term as the sum of those two numbers. 3 and 4 add together to 7, so it's 374. Cheat codes. Cheat codes. Right? Note, if the sum of the digits is a 2-digit number, make sure you carry any digits to the first one. Like 9 and 7 times 11 would be 16, so you'd add the 1 to the 9. So instead of 967, you got to add that 1 to make it 1067. So each of these tasks illustrates how a math problem can be solved using a shortcut. Polynomials divided by binomials without the use of long division. Yes, there's a shortcut to long division, but we are limited to it has to be polynomials divided by binomials. How can synthetic be used to find factors of polynomial functions? So there's an additional review on the history of long division. If you want to do some more long division before you start, x minus 4 divided into that, right? All the steps. There's all the steps to where we finally get this answer. We won't go through another example of that. Let's compare synthetic to long division. Okay, here is the long division solution. All right, there is the long division solution. All right, I'm going to write this one down and go through it on paper for the first time. 2x to the third minus. Now, I haven't done this since last school year. So I'm going to see if I remember all the steps for synthetic division, because you're my first class for Algebra 3. I have my other one tomorrow. So I'm going to see if I can remember how to do this, because synthetic division is a lot easier for the same problem. You see all the steps of that problem there. If we were dividing this by this, first I take x minus 4 equals 0. X equals 4. So I'm going to take 4. I'm going to write it like this. And I'm going to get the coefficients. That's a 2. That's a negative 3. That's a negative 12. That's a negative 16. Now, one thing I had to pay attention to when I did that is there's no missing terms. Third, second, first, no x. This is just like polynomial division. If I was missing one, I'd have to put a 0. I got to put that 0 coefficient in there. Here's how this works. First, I'm going to bring down the first number to 2. And I'm going to take 4 times 2. Put these in your notes. 4 times 2 is 8. I'm going to add these together. I'm adding. Negative 3 times 8 is 5. So now I'm going to multiply that. 4 times 5. 20. Add these together. Negative 12 plus 20 is 8. Again, 4 times 8. 32. Negative 16. All right, I've got my answer. You're like, wait a minute, I don't see an answer yet. I haven't written the answer, but I have it. This started with an x to the third. So my answer starts with an x squared. I have to subtract 1 because I've divided an x out. What's the coefficient? 2. What's my next coefficient? 5. And since that's the x squared, this is the x. What's my next coefficient? 8. And this was an x, so this is the constant. So what's this number? That's the remainder. There it is. That's the answer. All I did was took the coefficients, I took what x equaled in this, and I divided that number into those by doing this. Drop that down, multiply, add, multiply, add, multiply, add. There's my answer. 2x squared plus 5x plus 8 plus 16. Now let's see if I actually did that right. 2x squared plus 5x plus 8 plus 16. That's the exact same answer I just got. They did it through all this long division. I did it with synthetic division shortcut. Let's see. There's what they did. Synthetic, put just the coefficients. Took the 4. Dropped the 2 down. 2 times 4 is 8. Add those together, you get 5. 4 times 5 is 20. Add those together, you get 8. 4 times 8 is 32. Remainder of 16. This is the opposite. X minus 4, so x equals 4 if you set equal to 0. These are the coefficients. These are the numbers as you multiply through. And that's the coefficients of the quotient. The 2, the 5, the 8, and the 16 remainder. And just like in long division, if the resulting remainder is 0, then the divisor is a factor. Okay, synthetic division and long division are two valid methods for dividing polynomials, but note some of the limitations exist. This is important. I'm going to write this in my notes separately. Synthetic division. All right, only in capital letters. Only works with, let's see, how would I phrase it? A divisor of x. Not x squared, not x to the third, etc. Only x to the first. That's the limitation. It only works, I guess I can make that R look more like an R. If this was x squared minus 4, I couldn't do it. It doesn't work. It does not work. That's the drawback. Synthetic division only works with a divisor of x, not x squared, not x to the third, anything else, only x to the first. So that's the important thing to understand. That's the important thing to understand. You cannot do the big problems that have the x squared, x third, anything like that. Only x. So I wanted to write that in the notes rather than just reading it on the screen because I want you to remember this. You might write that in your notes just so you don't sit there and you're working a long time trying to solve one of these problems and you can't figure it out. That's because you may not be able to use synthetic division on it. All right, let's go back here. Here it talks about to use synthetic division, the divisor must be a binomial of degree 1. That's what I'm saying. It has to be x to the first. Has to be x to the first. If it's a monomial, trinomial, or polynomial, synthetic division not work. Oh, so that's another point. It has to be, let's put this word in there, binomial. What's a binomial? Let's talk about that real quick. Let's draw a line here. By 2 x minus 4 x plus 9. You could do 2x minus 1. That's going to be x equals a half, but you could do that. These are all binomials. Let's talk about what is not a binomial. Monomial. Two x, negative 3x, 7x. Those are all monomials. Mono means one. One means there's only one term. One term. These have two terms. See, two terms. 2x minus 1. What's a trinomial then? Let's look at a trinomial. So it tries. No, tri means 3, right? We know from English class, tri means 3. So that would be like x squared minus x plus 1. Or negative 3x to the third plus 2x plus 5. Or let's see, x to the fifth minus x to the third plus x. All those are trinomials because they have 3 terms.
When you're doing that
You have to have a binomial for that to work. These will not work. Must be a binomial, two terms, and it has to be an x, not x squared. So x squared minus 4 would not work. X squared plus 9 would not work. 2x to the third minus 1 would not work. It is a binomial, but it's not x to the first degree. So yes, no, no. So that's the big thing to understand about synthetic. When can I use it? When can I use it? This is the only time you can use it. Now, fortunately, we're going to have some problems that qualify because they want us to practice with synthetic division. But it's just important to understand when yes, when no. When can I use it? When can I not? All right, using the same example, identify the opposite. X minus 4 becomes a 4. The coefficients, 2, -3, -12, -16, and then solving it. Drop that first term down, and then multiply and add all the way through. What would have happened if the opposite sign of the constant divisor? What if they use -4 instead? It's x minus 4 and you use minus 4? Totally different answer. 2x squared minus 11x plus 32 with a remainder of a negative 144. That's not even close. Only thing to get right was the 2x squared. Everything else was wrong. So that's why you got to make sure if you have x minus 4, what is x if it equals 0? It's 4. All right, let's go to page 2. Notice there's not many pages in this because synthetic division is pretty simple. If you can use it, when you can use it, it's pretty easy to do. So let's watch them do one here. See how long it takes them to do this. The long division took them like 4 minutes plus. This takes 2 minutes and 40 seconds.
The first step in the synthetic division process is to set up the problem. Start with the divisor. Identify the opposite of the constant. In this case, the constant is 7, so -7 is used. Place this value in the top left corner of the synthetic division problem. Drawing half of a box helps to separate it and reduce possible confusion.
Now notice I said just take x plus 7 equals 0. They just said take the opposite of 7. Either way, with x plus 7 equals 0, you subtract 7 from both sides to get x equals -7. I just like making it easier to remember how to get that -7 rather than just saying take the opposite sign. But whichever way works for you.
Now look at the dividend. Identify the coefficients of the terms in descending order. Remember to show the understood coefficient of 1 for x squared. Place the coefficients along the top row of the problem to the right of -7. Underneath those coefficients, skip a line and then draw a line. Now the problem is set up. Begin the synthetic division process. Start by bringing the leading coefficient under the line. Multiply the divisor by the number beneath the line. Place the product underneath the next coefficient. The vertically aligned numbers are added and the sum placed below the line. Repeat the process until all numbers have been used. The final step is to translate the synthetic division process into a solution. The bottom row represents the coefficients of the quotient. Since the dividend has a degree of 2, the quotient will have a degree of 1. The last number is 0, which indicates there is no remainder. Check your work by multiplying the quotient by the divisor. If the result is the dividend, the quotient is verified. Use FOIL to multiply the binomials. Combine like terms and there is the original dividend. It worked!
All right, it worked. And since those end up no remainder, that's the actual factors. X plus 7 times x minus 9 is x squared minus 2x minus 63. So that is the actual factors of that quadratic equation. So found with synthetic division, quicker, easier than polynomial division. So here's another example right here. Let's check this one out. This one's 2 minutes and 5 seconds. And this one they're not going to talk through, so let's pause it and see what they've done here. So they got the divisor of x plus 5. So that means x equals negative 5 if it's set equal to 0. And that's going to be your divisor term for your synthetic division. So they're dividing into x to the third plus 3x squared plus 25. So when we write the coefficients, we have to recognize, wait a minute, we're missing a term right there. So our coefficients for the x third is 1, 3, 0, and 25. So let's see, they should go through that. So there's a missing x term. So we have to put that 0x in there before we take the coefficients that we need. So we got the negative 5 being divided into the 1, the 3, the 0, and the 25. Now we can start the synthetic division. Draw your line at the bottom. You're going to drop the 1 down. Is the first thing you do is you need that first coefficient just to come down. Then you're going to multiply the negative 5 times the 1, put it underneath the next coefficient, add those together, so give you a negative 2, multiply that now times the negative 5, put that under the next coefficient. So you have 0 plus 10, bring the 10 down, multiply that times the negative 5, put then the next coefficient, and finally you have a remainder of negative 25. So now since we started with an x to the third equation, and we divided the x out, our coefficients all drop down 1 degree. So we have a 1x squared, a minus 2x, and a 10 that we got from our answer. That's the coefficients we got, 1, negative 2, and 10. And then the negative 25 is our remainder. Okie dokies. So create your own 5th degree polynomial. Oh, this was interesting. They want to work backwards. Let's say we're dividing by x minus 4, and we're going to create something that ends up with a remainder of 1. Wow. Okay, so said, all right, let's so it'd be a 4 since that's x minus 4. Well, let's just play with this one. Yeah, let's just play with this. I don't know that I've ever seen us have a problem like this, but I think it's very interesting. So let's switch over to our other paper and try that, because that'd be an interesting way to work a problem. So they want, when we divide by x minus 4, they want a remainder of 1. Remainder, I'm trying to write 2 things at the same time. A remainder of 1. So how do we do that? So we know we're dividing by a 4. And they said they wanted a, was it a 5th degree? 5th degree. So they want a 5th degree. So if we would start with like a 2x to the 5th and to the x to the 4th, x to the 3rd, x squared, and then we need an x term, don't we? and then just finally a plus or minus at the end, plus 11. So that's 2x to the fifth minus 4x to the fourth plus 5x to the third plus x squared plus 7x plus 11. That's the one I've made up. But they want to only have a remainder of 1. But this is what I've got so far. This is an interesting math experiment to see if we can create our own. So let's do the division. If we divide it by x minus 4, so I take the 4, 2 comes straight down. 2 times 4 is 8. Add those together, I get a positive 4. Those multiply to 16. Add those together, I get a 21. Oh, this is getting bigger and bigger because I didn't put any negatives in here, only at the beginning. This is 82, so now it's 83 when I add it to the 1. Woo! 4 times 83 is 330 to 332. And then when I add that, I get 339. I really should have done some negative coefficient somewhere. 4 times 339. Well, let's do that. 339 times 4, 36. That's a 5, carry 1. So that's 1356. And obviously I don't have a remainder of 1. So this would be, let's do this. Let's change this from a plus 11 to minus 1355. Minus 1355. Negative 1355 plus 1356 is 1. There, I did it. That's the remainder. So x minus 4 divided into 2x to the fifth minus 4x to the fourth plus 5x to the third plus x squared plus 7x minus 1355 gives me a remainder of 1 because I added 1356 to the negative 1355. But if I would have put some negatives in here, that would have kept those numbers smaller. Put some more negatives. I just had the 1 negative. So it was small at first, but then it started growing really big, really fast. But that was a fun thought experiment. There's an infinite number of right answers for that. This is just one. See, because they chose different coefficients. They put negatives in there. They were smart. They put a 1, a 2, a negative 20, negative 25, negative 5. So they ended up with x to the fifth plus 2x to the fourth minus 20x third minus 25x squared minus 5x plus 165. They didn't have to have a 1,355 that I had to have. So, all right. But that was just kind of a little fun, build your own. Look back at examples. One of them had a remainder of 0. It wasn't that one. I don't think it was that one either. But this first one had a remainder of 0, I believe. Why is that important? Remainder 0 says that's a factor. It's a factor. More on synthetic division and the lesson summary. Let's look at the lesson summary. It just tells you the steps. So if you have this divided by this, set up the synthetic division problem. You take x plus 5. So you take negative 5 as the divisor. Since you have this equation, you have to put that 0 term in there because it's missing the x and just pull the coefficients. Then follow the synthetic division process by multiplying and adding. Multiply, 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 add. And then you just write the answer. Remember, if it's x to the third at the start, you're x to the second in your answer. You subtract 1 degree, and then all of the terms just go down from there. X squared, x, and a constant with the remainder. And if the remainder is 0, that's a factor. All right, lesson summary. More on synthetic division, more examples. Work out the synthetic division, enter the solution. So here's a practice problem for you right here. Take this with synthetic division. What goes there? Well, if it's x minus 1, then from right there, we're going to put a positive 1. Excellent, because we put a positive one. Next. Now it wants to know what are the 5 boxes. Well, 3x to the 4th. The first one's a 3. Negative 7x to the 3rd. Negative 7. 10x. Oh, wait a minute. What happened to x squared? There's no x squared. So we have 0 x squareds. We have 10 x's. And we have negative 5. Submit that. Correct. So this will walk you all the way through there. There's 2 more steps. So do this right above the lesson summary. Do this and see if you can fill in all the blanks. This is a great step-by-step. Right here, you should go in and do this. Go to page 2. Go to the synthetic division problem and see if you can fill in all the boxes. What goes there? That's where you put the answer. Submit it and go. And it'll step you through 1 of 4. And that will walk you through step by step by step of doing synthetic division. Great thing for you to do right there. Then we have a page of practice problems. 2x to the 3rd plus 6x squared plus 9x plus 10 divided by x plus 2. 6 problems. They gave you 6 more problems. So let's do one more problem since I got a few minutes here just to work one problem to give you one more example that we did in class. Okay, got this written down. So x plus 2. So we're dividing by minus 2. Our coefficients are 2, x to the 3rd, x squared, 6, x constant. Okay, we weren't missing any terms. So we can just do straight across here. Bring the first one down. Negative 2 times 2. Add those together. Negative 2 times 2. Add those together. Negative 2 times 5. Oh, look, no remainder. So our answer when we divide by x plus 2 is started with a 3rd. So now it's 2x squared plus 2x plus 5. So this is a factor of this, and it leaves the quadratic. And then you can factor that and know all 3 factors of this right here. But that's our answer. Let's see. It wants to type that in to see if we're right, or does it just show us if we're right? Oh, here it is. 2250. Yep, that's what we had, 2250. And then here's another one. And another one, another one, and another one. So there you go, 6 problems. Oh, create your own second degree when it has a remainder of 7. Another little fun one for you to try there. All right, let's look at the assignment that goes with this. What is the quotient when you divide this by x minus 2? What's the quotient when you divide this by x minus 2? How about this one by x plus 3? Given these binomials, x minus 1, x minus 3, x plus 3, or x plus 5, which one of those is a factor of this? So you may have to do 4 of them to figure out which one has a remainder of 0. Or you might guess correctly the first time, right? So you'll have 1 to 4 different divisions to do, but it's synthetic, it's faster. And here's another one. Gives you 4 different factors. Which one of those actually divides into that with a remainder of 0? 5 problems. Suffer through the long division, but it's good to understand that because we can't always use synthetic. Remember those conditions. Can't always use, so we need to know how to do long division. But second lessons, all synthetic. Hopefully practice that enough. Again, go right above that lesson summary and see if you can step through that properly. Try those practice problems on page 3. Because the more you do synthetic division, the easier it gets. And I want you to make it real easy for yourself. Because you never know when you might be able to use that. Anytime you're dividing by that little binomial, you're like, oh, I can do synthetic division. And it'll be very fast if you've practiced enough. If you haven't practiced enough, you'll forget something. You won't put that 0 term in there because it's missing that, or you'll miss something in the process if you don't practice it enough to get good at it. So do the practice problems. Do that one step through right above the lesson summary on page 2 and get good at it. So, all right, guys, there's only 10 minutes of class left. So we're going to we're going to end it there. I hate using up all this time, but this was some good stuff this week. We had to get to this synthetic division and all that stuff. And it'll be downhill from here. Now that we got the shortcut. Now we have the cheat code. We're good to go. All right. It is a B-Day Friday. So we will see you Wednesday if you need to be here or if you want to be here. So have a great week.